We're going to look at mole worksheet number 4, but what we're really going to do is do two problems for this one. The first one, how many moles of water are in 5 barium chlorides trihydrates? Now in this one, a lot of people in the past have made the mistake of saying, hey, it's 3. But what we're really looking at here is the fact that for each 1 barium chloride, I have a total of 3 waters. You can almost think of this, well, you can think of it like this. So the coefficient in front of the water just tells us how many waters go with each barium chloride in this case. So if I now have 5 barium chlorides, I would then have a total of 5 times 3 waters. You can almost think of it, don't write the parentheses when you do your homework, but you can think of it like this. I have 5 of the barium chloride trihydrates. So 5 times 3 waters for each one gives me 15 moles of water, H2O. So for each barium chloride, I have 3 waters. Since I have 5 of the barium chlorides, I have a total of 15. So this would be 15 moles of H2O. Now in the second question here, completely separate question. It says, what's the percentage of water in copper 2 sulfate heptahydrate? So you have to figure out what you have first. With the copper, transition metal, the Roman numeral tells me it is a +2 charge. I then have sulfate. Sulfates are SO4, 2-, polyatomic ions, and heptahydrate, hydrates are H2O, and hepta means I have 7. So I'm going to write this formula. The first thing I have to do is I have to balance the ionics, and I get, for every 1 copper, I only need 1 sulfate. Now my charges are balanced, that's neutral. And for every single copper sulfate I have 7 waters. How do I know that? The prefix, hepta. So that is actually my formula for this. So now I need to figure out what's my molar mass. This one gets to be a little bit more interesting. If I'm going to figure out the molar mass of copper 2 sulfate heptahydrate, I'm going to have to write down all the different elements that I have. I have copper, I have sulfur, I have oxygen, and I have hydrogen. Now I have oxygen again from the waters, but all I want to do is keep track of the total number that I have. So the coppers, I only have 1 copper. Sulfurs, I still only have 1 sulfur. Now for the oxygens, you'll see I have 4 here, but I also have oxygen over here. And for every single copper sulfate, copper 2 sulfate that I have 7 of these waters. So what I really get for oxygen is going to be, I get the 4 from the copper 2 sulfate, plus I have 7 waters, which is 7 H2Os. I have 7 from each of the water molecules that is attached. And then finally for the hydrogens, I have 2 hydrogens per water, but I have a total of 7 waters. I have 14. So that's how many total elements I have in here. Now all I do is I go to the periodic table and I write down their molar mass of each. For copper, it's 63.55 grams. For sulfur, it's 32.06 grams. For oxygen, once again, I'm only taking them 2 decimal places, 16.00 grams. And finally, for hydrogen, it's 1.01 grams. Go ahead and multiply these out and add them up, and I get a total of 285.75. 285.75 grams. That is the molar mass of copper 2 sulfate heptahydrate. So with that being my molar mass, now I want to know what is the percent water. So remember, percent composition equals what part you're looking at over what's the mass of the whole thing, which we just calculated, the mass of the whole thing, times 100 to put it in a percent. So our part, we know percent water is going to be, hey, we better figure out the molar mass of water. The molar mass of water, you add together 2 times 1.01 plus 1 oxygen times 16.00, and that's equal to 18.02 grams. So that's of one water. Now to get of all the waters, since it's heptahydrate and we have 7 of them, we have to take 7 times 18.02 grams. And from that one, we get 126.14 grams. All right? And that represents my 7H2O that's in the formula. So now my percent water is merely going to be 126.14 grams, the weight of the water, the mass of the water, I should say, divided by the molar mass of the entire compound, 285.75 grams. Make sure we get the decimal in there. Multiply that times 100. And my water as percent composition is going to be 44.14%. And that is the answer.